hope is that this competition will continue to challenge students to think about math in combination with social, political, economic, and global business issues for years to come. I'm pleased to report that this year 1,128 teams comprised of almost 6,000 students from 45 states in the District of Columbia participated in the competition. I would like to acknowledge the contribution of the team coaches. We hope you will continue to encourage your students to consider careers in math, economics, and finance, and to enter the pipeline of highly talented candidates for Moody's and other financial services firms who will compete to hire these students as fundamental credit risk analysts, economists, software developers, quantitative risk specialists, and so forth. As I mentioned at the breakfast, scholarship winners of the Moody's Mega Math Challenge are invited each January to apply for paid summer internships at Moody's Corporation. Internships are a very important part of our recruiting effort, and we are always interested in attracting students and students of diverse backgrounds to Moody's. We are very pleased to have the members of the first champion team from 2006, hailing from Staples High School in Westport, Connecticut. So let me call up now Miles Lubin from MIT, Elizabeth Marshman from Stanford, Andrew Sherhart from the Office of the Comptroller of the Currency to the podium. They will say a few words about their participation in the Moody's Mega Math Challenge and its impact on their education and career.
Hi everyone. So as Fran said, we are 3/4 of the inaugural winning team. My name is Elizabeth, and this is Miles and Andrew. And we've been talking a lot about STEM education today, but we'd love to talk to you, especially you folks, a little bit about what that STEM education actually applies to. So all of us are just 5 or 6 or so years out of college, and so we'd love to give you a little snapshot as to how we use applied math in our careers now.
So I'm Miles Lubin. I'm currently a PhD student at MIT in operations research. And one of the applied projects that I worked on is mathematical modeling for integrating renewable energy into the power grid. So very much in the spirit of mathematical modeling and what we do in this competition. And I guess one of the biggest decisions that most of you will need to make soon is what you're actually going to study in college. And I'd say that for me, in high school I had a lot of interests. Math was one of them, also computer science, languages. Everyone has more than one interest. And I think that this contest really focused me on applied math and helped me decide to take applied math as my major. And that's what I did. And so the competition really stays with you. So one story is that I have an academic webpage. I have a little link at the bottom saying, here's a little article from high school pointing to the Moody's Mega Math Challenge. And when I was visiting graduate schools at a certain school, talking to professors, the first thing they said, oh, that's a really cool thing you did. And that was like something 6 years ago. I hadn't even thought about it. But it really stays with you, and so it's something to be proud of, and congratulations.
Thank you. My name is Andrew Sherhart. As mentioned, I'm currently working at the Treasury Department. I wanted to very much thank Moody's Foundation and SIAM for inviting us all back here today. And I was just amazed at the presentations today. Someone made a joke this morning that in the inaugural year, there was something like around 100 submissions to the competition, and this year there was over 1,000. And so by my mathematical modeling back the envelope computations, that means that you're all 10 times as smart as and it seems to have showed in these amazing presentations today. So yeah, just a little bit about where I've gone from here. I work in an economics group at a banking regulator at the Treasury Department. I've been working a lot on researching mortgage markets, consumer lending markets. Just some concrete examples. I've worked on a project where we were looking at administration responses to the foreclosure crisis. Someone mentioned this morning determinants of mortgage default, mortgage foreclosure. That term is ubiquitous where I'm currently working, and another project that I've worked on has been looking at certain aspects of money laundering in financial institutions, and sort of just how this applies to the competition. I think I've always found in my work that those that tool set of applied mathematics, analytical skills has been super helpful to me. There's a lot of times when my comparative advantage has been that mathematical background, because everybody else in the room has way more experience to draw on, and what I can bring to the table is a mathematics background, and that's been super valuable. And just even if it's not a larger scale project, maybe someone just calls you on the phone, as happened to me a few days ago, and says, Andrew, I have a question about like survey sampling. I don't understand this one thing, and that can blossom into a bigger project. So even in the day-to-day interaction, that kind of tool set really has meant a lot for me as going forward. So thank you very much.
So for me, after I graduated from college, I went into the medical device industry. And even as recently as a month ago, I was using mathematical modeling to model people's gaits. And I've been working on a prosthetic knee that is eventually going to be distributed across India, and how we figure out the different forces that the knee needs to withstand, and especially in uneven ground, if you can imagine unpaved roads. That's all done by mathematical modeling. So as you can see, there are a wide range of applications for applied math, and we really look forward to the different roads that your careers will take. So thank you.
Thank you, Miles, and Elizabeth, and Andrew. I just want to point out that they were the original winners that came from Staples High School. And we have a team in the top 6 this year, also from Staples High School. So they must be doing very good things in Westport, Connecticut. Before we announce our winners, I would like to welcome Dr. Rachel Levy, who is representing SIAM today. Dr. Levy is an associate professor of mathematics at Harvey Mudd College and the incoming associate dean for faculty development. Her research focuses on the mathematical modeling of fluid motion. She serves as the Vice President of Education for SIAM and is on the editorial board of Math Horizons magazine. At Harvey Mudd, she is a faculty mentor for the Mathematics Clinic program, in which teams of students solve problems for business, industry, and government sponsors. She is also the creator of the blog Grandma Got STEM, which celebrates the stories of senior women from all over the world who have worked in STEM-related fields. Most recently, she has been working with teachers to develop mathematical modeling curriculum for elementary schools. So let her know if you have an idea, a modeling problem idea for young kids. She would enjoy hearing that. Dr. Levy.
Thank you so much. It's a delight to be here. I've known about this competition for a long time, but I haven't really participated in this part, and it's so exciting. And was such a delight to hear all of your presentations earlier, so thank you to Moody's, and congratulations from SIAM for being here. So I'm just gonna torture you for a few minutes, because I know you're very nervous and you wanna hear the results. But I wanted to tell you a few things that maybe will stick with you. I'm going to teach you the most important thing that you need to know as a mathematician, okay? So when I'm working, I work in fluid mechanics, and I'm in academia, which means that to some degree, if I can get enough funding to support my students, I'm at Harvey Mudd College. We have all undergrads, all studying STEM, and I can kind of do what I like. So I've studied the surface pattern on the ocean when whales are swimming. I've studied the coordination of underwater robots, and I've studied the fluids in your lungs. And every time I've studied these problems, which are very interdisciplinary, they've all gone better if I've talked to chemists and physicists and biologists, right? And interacted, and of course you have to go whale watching. if you're studying whales. So when I moved to California, I was like, I gotta do a problem on whales, because I want to get out and do some whale watching. So you also can combine, like you said, the things that you love with the work that you're doing and important questions that people want to answer. And it turns out that those surface patterns are not what was on the web. So if you looked up the answer on the web to what the surface pattern was, it was wrong, right? And we figured out what was really going on. So you can kind of see something that seems curious and pursue it and answer those questions with mathematics. So that's really exciting. So you usually see something that seems a little strange or something that needs explaining, and you think, oh, I want to figure that out, and you bring the right team together, right? And then you get it wrong. Do you know that part? Remember that part? Yeah, you get it wrong, and then you're like, that's wrong. And so then you bring more people together, you try, you bang your head against the wall, you're like, that's still wrong, right? And that's a lot of what you do is you persevere through the times that you're wrong, okay? But then when you're really working hard and lucky, and you've got the right team together, sometimes you're right. And when you're right, you get to write papers, and you get to go to conferences, and you get to tell everyone in the whole world what you figured out. That's so cool. And you do the most important thing a mathematician can do, which is the mathematician's happy dance. I hope you did it when you submitted your papers. And I hope you did it when you anticipated coming here. But there's an old cartoon called Peanuts, and it has a dog in it, Snoopy, and Snoopy has big ears and big feet. And when he's really happy, he almost levitates. And his feet kind of go like this. So the mathematician's happy dance kind of looks like this. The ears, the feet, the whole thing. Oh, I got it right, and you don't do it alone, right? You do not do the mathematician's happy dance. I mean, you can, but it's so much more fun when you do it with your team, right? Because at Harvey Mudd, we ran out in the hall, and we're like, I got it! And we all do the happy dance together, right? Okay, so now you know. So when you do something right, which is not maybe even most of the time, you deserve to do that, right? Okay, so I didn't always think that I could be an applied mathematician, actually. And I really didn't see a lot of mathematical modeling until I was a senior in college. And I wondered where I would fit into your models because I was an English and a math major. Was I a STEM major or not? I don't know. No one really addressed that. But anyway, I was an English and a math major, and the English department was pretty sure I would be a mathematician, and the mathematics department was pretty sure I would be like an English major person, and so neither of them were really interested in my career. But there was a class called Operations Research Practicum, and we worked for NASA, and we got to work on the space station, which wasn't up in space yet, and we really didn't know if it ever would be. And they needed to understand how to deal with energy, with the battery cycles, with the solar cycle and the eclipse cycle. And if you didn't solve this problem correctly, and you had some choices to make. So you have like a lack of energy, and now you have really expensive experiments that someone sent up into space, right? And they really care about them, and maybe they're really expensive. So you gotta decide, am I gonna kill that payload, which earns money for NASA, or are we gonna kill the astronauts, right? I mean, neither are a very good option. And then if we're gonna kill one of these experiments, how do you choose, right? How do you look at the power usage of that experiment to decide which one you're gonna kill? Because probably once you turn it off, it may be done for. Okay, so this was really fun problem. It was very exciting. But when I graduated, I still didn't think I would be an applied mathematician for like 10 years. But it was always in the back of my head how much fun that was. And I just kept thinking, I want to solve more problems like that. I want to learn more math. I need to learn more math if I'm going to solve problems like that. So it took me 10 years after I graduated from undergrad to go to grad school in applied mathematics. And partly it was just getting the confidence to think that I could do it. Because I wasn't sure that I deserved to do mathematics or do the mathematician's happy dance. I thought maybe that was for someone else. And why did I think that? Because the myth about mathematics is that geniuses do it, and they do it alone. I don't know how many days you wake up and feel like a genius, but remember all that getting things wrong before you get things right? I mean, that doesn't really help, right? So this idea that geniuses work and they work alone, it's a complete myth because as you know from your experience, you're better because you were a team. There's some ways that being a team is harder, but you are better. And even the mathematicians that really hate working with humans that are living and breathing next to them are still interacting with mathematicians because they're reading their papers, right? No mathematicians are working alone. So this idea that there's some genius out there that's working alone, that is a complete myth because they're using all the tools that come from all the mathematicians before them. So mathematics is inherently a team sport, no matter how you play it, right? So you guys have worked really hard and your presentations were really good. And so the one message I want you to go home with is, first of all, you have the right to do mathematics. And you have a lot to contribute. And now you have this experience of mathematical modeling that you can go share with high schools when you're in college. And you can be a part of the SIAM community, so the Society for Industrial and Applied Math is where we get together to do the mathematician's happy dance, especially in terms of industrial and applied mathematics. So I hope I will see you all at SIAM meetings. And I hope you will come up to me and say, I gotta tell you the coolest thing I figured out, and we'll do the mathematician's happy dance together. Meanwhile, no matter what happens right after I talk with these rankings, you have earned the right to go home and do the mathematician's happy dance.
Okay, so when I call your name, when I call the name of your team, please come up here and we have a big check that will go in your front hall of your high school. So let me tell you a little bit about the Moody's Mega Math Challenge 6th place team. Members of this team enjoy hiking, video games, and playing the piano in their free time. One student loves reading about random topics of interest on Wikipedia. This team gives back by helping students who struggle with math by tutoring through math and science honor societies and volunteering as a sponsor for after-school clubs. Future plans include attending great schools for primarily STEM majors. Several students on the team mention engineering as a possible degree. They registered on December 1st. They downloaded at 7 a.m. They uploaded at 7:56. Oh, they were casual. 6th place goes to South County High School, Team 4187 from Lorton, Virginia. Coach Daniel Southard. Okay, the Moody's Mega Math Challenge, 5th place. Talk about an eclectic group. This team is made up of the president of the investment club, a competitive chess player, pianist, the team captain for Life Smarts, a competition about consumer knowledge. There is a competitive swimmer, a member of a Bollywood dance group, a tennis player, and a tinkling dancer, is this right? Tinkling is a popular form of dance from the Philippines. The students on this team volunteer activities include working at an area science museum, providing conflict resolution support for a local peace project, fundraising for cancer research, and interning in information security for a state health system. Their future plans involve the pursuit of various STEM degrees, including interesting potential majors such as theoretical physics and meteorology. They registered on February 6th. They were relaxed. They downloaded at 7:02. They uploaded at 8:56. They are Maggie Walker Governor's School, Team 4892 from Richmond, Virginia. Moody's Mega Math Challenge, 4th place. On this team is a musician who plays cello, guitar, piano, and plays violin for the school's symphonic orchestra. Another student speaks Korean at home in addition to studying Chinese. There's a modular origami folder, the captain of the basketball team, and a student who tutors several subjects and attends enrichment courses through a science honors program. Volunteer efforts on this team includes working for an after-school enrichment program for middle schoolers, guiding a museum's Echoes of Egypt exhibit, conducting clinical research for a local hospital, and assisting at a local social science degree, through a social sciences degree. They registered on February 11th. They were really early. They uploaded at 8:47 p.m. Fourth place goes to Staples High School, Team 5057, Westport, Connecticut. Third place, Brains and Brawn. This team is comprised of several athletes. Tennis, cross country, track and field, hockey, and football are just some of the sports that members of this team have been involved in. Fittingly, the team also boasts the Knowledge Bowl captain and the individual state champion in a math league. When they're not competing in math or sports, they enjoy reading, social outings with friends, and video games. Future plans for all team members involve college with a major in a STEM field. They registered on February 19th. They uploaded at 8:49. Third place winners are Elk River High School, Team 5560 from Elk River, Minnesota. Okay. The Moody's Mega Math Challenge runner-up, scholarship for $15,000. Members of this team play soccer, basketball, golf, or run track and swim. On the team are Science Bowl and Science Olympiad participants, the co-founder of the school's Latin Club, and a mock trial competitor. One student is passionate about music and sings and plays guitar and the viola. Another has spent time at two well-known universities doing chemistry research. Members of this team have supported surgery recovery patients at an area hospital, organized events through a random acts of kindness club, volunteered at a children's orchestra camp and a state natural science museum, and helped a church's ESL program. Members of this team all plan to tackle programs and careers in various STEM areas. They downloaded the problem at 7 a.m. They uploaded it at 8:53. They are North Carolina School of Science and Mathematics, Team 4904. Okay, so we know who the winners are, but you're going to hear about them anyway. There is an asteroid named after a student on this team, a recognition for winning second place in the Intel International Science and Engineering Fair. This team also includes a varsity tennis captain, a math club and science bowl captain, a student who hails from Nepal, and a team member who is an enthusiast of mental math, speed typing, and bullet chess. Opportunities to volunteer have taken these students to soup kitchens, to church as a Sunday school teacher, and to a local Chinese school as a teaching assistant. One student on the team has a rewarding experience serving as a translator and friend to a kindergartner in the district who recently moved from Israel. All members of this team plan to earn degrees in STEM-related fields. They downloaded the problem at 7 a.m. They uploaded the problem at 8:53. The 2015 Moody's Mega Math Challenge champions, North Carolina School of Science and Mathematics, Team 4902. Congratulations to all of you. We're very proud to share the room with you. I'm very proud to acknowledge your coaches. And now I invite you to go back and enjoy those chocolate-covered strawberries.